Good morning, good afternoon, and good evening, everyone. I'm Danny Smith, Executive Vice President and co-owner of Color ID. Welcome to Color ID's Campus Forum series, continuing the conversation. Today's session is titled Credential Technology and is the second session of the five-part third forum series. The third forum series will generally last about 60 minutes and run live each Tuesday and Thursday at 1 p.m. Eastern Daylight Time. Please feel free to invite colleagues from your institution or your company or anyone you know across the identity industry who would benefit from participating in the Campus Forum series. A registration link is located on our website at colorid.com. Look for the drop-down titled Webinars. At the beginning of today's session, relevant to the institutional attendees, there'll be a Menti poll to learn more about the common challenges you're now experiencing. It's simple to do. Just open a browser on a PC or mobile, go to menti.com. That's MENTI.com, and then type in the 6-digit code. We'll give you the code and explain more during the presentation. You know, it's really nice that we've been able to develop such meaningful relationships over the past 20 years, and we're incredibly grateful that we can come together today and stay connected. Once again, we have a large group of identity industry attendees joining us from all over the world, so as we say, whoever you are and wherever you may be, we welcome you. We hope that you find the investment of your time of great value, and we encourage you to be interactive in these sessions. Now, leading today's technical discussion will be David Stallsmith, Director of Product Management for Color ID. And David brings a wealth of technical information from over 14 years of working with advanced identity solutions. Of course, many of you know and have worked with David over the years as he works closely with manufacturers, vendors, and end users to promote the understanding of the complicated products and services that comprise our identification industry. He's contributed to the decision-making process at many universities, healthcare facilities, and government agencies as they have considered acquiring contactless, smart card, mobile ID, and biometric systems. And since 2006, David has presented annually at the NACU conference, and he's also presented at NACUS's annual and leadership conferences, the European and Canadian Campus Card Users Conferences, and full-day identity summits hosted by some of the most prominent universities in North America, excuse me. Joining David today on today's session as moderator is Mark Degran, Color ID's Corporate Marketing Manager. In addition to managing Color ID's marketing department for the past 16 years, Mark also juggles the duties of account representative for some of our most strategic partners, both customer and corporate. He's also the project manager for Color ID's banking-related customers. Mark and David's technical knowledge concerning advanced identity solutions is a testament to their commitment to our industry and a great example of the value differential Color ID employees bring to our customer and our corporate partner relationships. Now, just a few housekeeping items and we'll get started. As always, we're really encouraging these sessions to be interactive as possible, so please make sure you utilize the question box to submit your questions, and all questions will be answered at the conclusion of the presentation during the Q&A. In addition to asking questions, there will also be live polls throughout the presentation. And please be sure to participate in those, and please be as prompt as possible. Also, please note that Color ID's entire higher education team is listening in on today's session and are available for any questions or follow-up discussions. Just call or shoot your account manager an email. Also, a reminder to everyone who completes the 5-session forum will receive a certificate of completion and also a Color ID swag bag filled with some really nice stuff. Color ID can confirm everyone's attendance, so you don't have to do anything regarding that. However, each session does require a separate registration, so please make sure you register for all the future sessions. Thanks again, everyone, for the privilege of your time and for keeping us connected. Now I'm going to turn this over to David and Martin to get started. David?
Thanks, Danny, and hello, everyone. Welcome to our webinar. We're going to continue the conversation, and we're going to start off with a word cloud that Mark will introduce.
Hello, everyone. So, like Dave and Danny just said, we're going to launch this off with Menti. So if you could travel to www.menti.com, it's going to prompt you for the code 11343. And we just ask that you answer this question that you see up on the screen. How do you feel about your card program right now? So once we start seeing answers getting submitted, we'll see them on the board here. And collect this data. We will be sharing all of the surveys and poll questionnaires throughout the presentation. And we'll be sure to send you a link of all of the recordings at the end of the sessions. All right, nothing yet here. There we go. We got one coming in. Somebody says they miss it. Yes, I unsettled. Understood there. Certainly appreciate the missing it and unsettled. I mean, these are very unique times. Let's see here. Someone must be on the up and up with their card program, saying that it's excited. Someone feels a little bit behind the times. So looks like we got a good variation of folks here. Learning experience. Okay, so if you see a larger word like learning experience, that means that somebody else chimed in saying the same exact thing. Headache. Okay, old, plain, stressed. Okay, some good responses. Thank you, everybody. So we're going to have a couple other polls throughout the presentation. I'll handle those. So whenever those come up, just be sure to jump on real quick, submit your answer, and we'll keep the ball rolling. Dave, I don't know if you want to close down the polling, and we'll get this going.
Great, thanks a lot, Mark. And interesting responses there. It is definitely unsettled times. I don't know quite what to expect. However, when we get to plastic cards, we kind of do know what to expect because they've been with us for a long time and they will be with us for a while longer. So today we're going to talk about how and where they are made, what kind of tech you can get in those cards, and how that tech is programmed, which will include access control card formats, a perennial favorite, and then encryption and interoperability. So let's get started. Talk about the plastic itself. And it's easy to forget that as you know, we're looking beyond plastic to other types of credentials. The plastic card itself is still a complicated little bit of machinery. And here is a machine, a fabrication machine designed just to put the mag stripes on the cards. And you can see in the tray on the left side of the machine there, a bunch of mag stripes that have been laid out onto a plastic sheet and tacked onto it. And that sheet will be the final layer of the many layers that make up a card. And if any of you have ever had the experience of trying to order a different color mag stripe than black or dark brown, or you've tried to order a second mag stripe, this kind of machine right here explains why you might have had a very large minimum order quantity. For example, if you wanted a blue stripe, because the manufacturer had to order a great big roll of blue mag stripe material to make however many cards you wanted, and maybe enough for, I don't know, another 8 or 10 years. So this is just the beginning of the card process, putting the mag stripe on the final layer. On the left here is a picture of 21 cards on a single sheet printed. And there are litho and then digital litho presses that print these images on the cards. And this is again going to be just another sheet made up of that will go into making up the card as demonstrated on the right. And so you see on the outside is a clear layer, and then in the middle is a printed layer. In the very middle is a layer that contains the chip and the antenna, or just the chip itself. And then the layer on the bottom has the mag stripe. Those are all those sheets for however many cards are going to be cut from each sheet, and they can vary from 21 to 70, at least in my experience. Those sheets are laid together between highly polished sheets of steel or some kind of sturdy metal, and kind of like cookie sheets, and that's what this technician is doing right here. He's layering the sheets between the platens, and then he will pick up the assembled group and insert them into the slots behind, which are it's an oven, and they will be subjected to heat and pressure over a period of hours, and then cooling, so that the layers of the card are all fused together. And if any of you had the experience with plastic cards at any time of them delaminating, and I don't mean the extra layer that you might have put on in your printer not adhering well, but the actual the card itself coming apart, this is just part of the process. Occasionally something doesn't work. Maybe the oven doesn't work, the laminating machine hasn't been exactly calibrated, or perhaps the plastic was a little different, or an adhesive between the layers of plastic was a little different. Years ago, there was a problem that went on for months because one of the companies in the whole world that manufactured the composite layer, in other words, a polyethylene layer that went into a PVC card construction, so that it was now a composite of two different kinds of card layers. That manufacturer went offline. They had some trouble in their manufacturing facilities, and nobody could get the polyethylene for the PVC cards, or polyester, whichever. And so for months, composite cards were unavailable, and it was because one supplier in the global supply chain was offline. Speaking of global supply chains, as we've all become very aware in the last month and a half or two, supply chains have changed and been disrupted or just slowed down. And so not too long ago, one of our major card suppliers told us that they also are experiencing some disruption in their supply chain. So if you're ordering in general, I think this is a pretty good rule of thumb. Keep in mind, because when people arrive back on campus, they're going to want cards. You're going to want to have cards to hand to them. So if you're able, you might want to order early, even though your arrival date, it may have been pushed back, because if the card items are in stock, then they will ship right away. But if they're not in stock, of course, they will ship later. And why? Well, during the shelter-in-place restrictions, some facilities were shut down, some were operating under exclusion, some had reduced workplace labor, all the different things that we've seen in the news. We know about this is also affecting the card industry. And also logistics have been crazy constrained. A lot of cards travel by air, and we know that air cargo capacity has been reduced, for people and for stuff. So just keep in mind, if you are planning to order cards, probably as usual, sooner is better than later. So we've addressed the plastic part of the cards themselves. Let's talk about contactless chips in those cards. And let's start off with a poll. Mark?
Thanks, Dave. So, first poll. What technologies are on your cards? So please just select all that apply. And as the votes come in, thank you guys. You guys are off to a quick start. Much appreciated. And I'll close it down, and then we will review them together. All right, here we go. 82% magstripe. That makes sense. Seems like everybody in the world uses magstripe, or at least in North America. 55% are utilizing a barcode. Now that could be a 2D barcode as well. 45% have a high frequency I-class family chip. That'd be the SE or CEOS line. And then 27% utilizing a MIFARE. That could be your classic DESFIRE EV1, EV2. And then lastly, 18% of you are using the low frequency PROX. So that's your old school 30-year-old technology that is 125 kilohertz. So good variation there. A lot of different technologies on the cards.
All right, thanks, Mark. Interesting, the barcode is down around the 50%. We're seeing that in these polls as we've done a number of these presentations. Barcode was early on the dominant automatic ID on a card, because a lot of cards are made for library use first. They were library cards, and libraries loved barcodes. So we have to assume that either people aren't using their cards in the libraries a lot, or the libraries have upgraded from barcodes. Couple things about barcodes. First of all, they take up a lot of landscape, these linear barcodes, and they're very easily copied. So you can Xerox that thing and tape it to another card, and you are somebody else to the barcode reader. So they're inexpensive, they're effective, they're also very low security. The QR barcode, if they are dynamic and generated for each transaction, are very secure. But again, if in most cases that's not the case when they're printed on a card, and so even though it's a QR code and it looks different than a 2D barcode, as this is called, a linear barcode, if it's static, it can be copied and it's read by an optical reader. So a copy machine is your cloning device. For MagStripe, it has really hung in there in the universities because so many systems have MagStripe readers. And the reason for that is because MagStripes in North America took off in the 80s, really, certainly in the 90s, it became extremely popular, but MagStripe even, I guess, back into the late 70s. I mean, they've been around forever for the financial industry. So we've had MagStripes in our lives for a long time in North America. A lot of the rest of the world didn't have as many MagStripes and didn't have as much of the card usage and the back-end system that we have now. And so, you know, North America hung on to MagStripes in the financial industry much longer than a lot of the rest of the world who jumped to the contact chip. So in that case, in the United States in particular, was one of the later countries to the EMV contact chip party for financial cards, but MagStripes are still in wide usage, and at universities they just get the job done. However, as we all know, they're very easily cloned. You get about a $50 or $60 device, you can read that MagStripe and easily clone it, write it to another card with a MagStripe on it. So fine for low value transactions, not recommended for things where you need to guarantee safety of people or property. Visual security, a few years ago, had really dropped. Nobody really paid that much attention to what cards look like, other than if your logo was crisp and your photo was recognizable. But since a lot of driver's licenses and government agencies have gone to central issuance and they've bought great big expensive machines in an attempt to make their cards easy to recognize as the original documents that were issued. And they've done this by using very expensive machinery. They can produce these ghost images, microtext, laser engraving, things that you just can't do unless you have very expensive machines to do that. And so visual security has actually enjoyed a renaissance of interest and has lent security again to cards, at least from a visual perspective. So let's go to the chips themselves. The first chip we'll talk about, and in this group, a very small number of you have PROX chips, which is a good thing because they are, 125 kilohertz, low frequency. You heard the disdain in Mark's voice as he described the legacy technology of the PROX. It is old. And the problem is there's no encryption here. It can be very easily cloned. They were designed primarily for convenience. They remain very convenient, including to somebody who wants to fraudulently copy your card. And you can buy a device on the left there for 25 bucks. You can buy the stuff shown on the Fox 5 news report there on the right and put it in a backpack and read people's cards through your backpack and theirs, and then make clone cards. So the technology is not particularly secure as it was at the beginning. It was never secure in itself, but again, it was because you had to have expensive machinery to read and replicate early on, but that is no longer the case, clearly. And you don't even have to have your own machinery. You can go to Bed Bath & Beyond someday when they open, and if they have this copy any key locksmith in a box, on the left there is, right to the left of the blue ring, is a reader that will read your card, and then for 25 bucks, they will send you a clone of your card. So PROX is convenient and not particularly secure. In the 1990s, NXP, which at the time was Philips Electronics, later Philips spun NXP out to be their own company, but they started making a chip called MIFARE, and it's kind of an acronym, word acronym, but FARE is an important component because it was designed primarily at the time for fare collection on transit systems, and it was designed to be fast and inexpensive, which it is, still is, and MIFARE is still in use. And you'll in fact, a lot of hotels, when you go to the hotel and they give you a contactless card, if you have an Android phone, sorry iPhone users, you can download an NXP app and you can tell what kind of chip is on there. You can see where the programming is. It won't tell you the secret information, of course, but NXP does make an app for Android phones. HID introduced in response to these other card types. The PROX vulnerabilities were becoming known. NXP had the MIFARE chip. HID introduced the iClass, and it was their first entrance into the secure card world in the early 2000s. It was made primarily for physical access. It had a longer read range than MIFARE, not quite as long as PROX, but the goal was to keep the convenience factor high. The only problem with iClass is about 7 or 8 years after its introduction, some really smart European academics hacked an iClass reader, not the card itself, but a reader, and got information about how the iClass card was programmed that made it vulnerable to cloning in the future. So technology progresses and security continues to evolve, and MIFARE, cheap, fast, not so secure, was followed by several generations of other MIFARE named chips. And the latest, well, not the very latest one, but the one that really caught on as a secure chip was the MIFARE DESFIRE EV1. And it had really good encryption, AES 128, kind of a first for the industry in that regard. It was quick. It had a file system that was very flexible. HID, not jumping straight into the MIFARE DESFIRE EV1 camp at that point, I think it had not quite been introduced. First introduced a very smart solution in response to the iClass hack, and that was to encrypt and secure the data before it was loaded onto the chip. So this enabled them to keep issuing iClass cards, but now the data was securely encrypted, even though the card itself was the chip itself was known to be compromised. If you got the data off the chip, it wasn't useful. This would be like if you had a thumb drive. You plug a thumb drive USB stick into any computer, you can see all the files on there. If any of those files are encrypted, however, you can drag them onto your desktop, but unless you have the algorithm and the key to decrypt them, they still remain secure. You cannot see that data. So this is essentially what HID was doing with the secure identity object, the SIO, that became kind of the core of their new credential. So MIFARE DESFIRE EV1, this card that was introduced in 2013, 14 or so, has really gotten popular. HID makes MIFARE DESFIRE EV1 cards. Schlage, Allegion makes MIFARE DESFIRE EV1 cards for use with their readers and locks, and it has become the mainstay of the Transact, formerly Blackboard, access control system and payment system also. NXP making that chip, and it's being used by all those companies. If there is a DESFIRE EV1, is there an EV2 yet? And of course, the answer is yes. It was released 4 years ago. It is not really widely adopted yet. You can order them from a number of manufacturers, but not all manufacturers offer their programming on EV2. The main reason for that is because the security improvement for EV2 is really not so great as you would think, because EV1 was already very secure. What EV2 offers is primarily, in terms of an advantage, is a greater read range. EV2 had a very close read range, EV1 had a very close read range. EV2 gives you a little more range. It starts reading a little sooner. So EV2 feels faster. Also, it has some pretty cool features, but I haven't seen any applications in the university market, or really others I could imagine in payments or in transit perhaps. They might use some of these features, but it would take an enterprise level approach to take advantage of these features, such as derived master keys, key rolling, stuff like that. So really, EV2, the advantage is about the read range. Over at HID, who does sell the EV1 card still, they also introduced a new chip. They call it SEOS, S for SIO, which was that secure identity object, E for enabled, so SIO enabled OS. And it is standards-based cryptography, not unlike the MIFARE DESFIRE EV1 and 2 chips. It has the SEOS core, which is the encryption on the card that we've talked about that HID is using. And that is, if you have an HID system, they're reasonably priced and they are very secure, so they make a lot of sense. So let's review the card security levels, starting with the magstripe, and it had no particular security to speak of. Then PROX was introduced about 15 years later. Again, no real security other than that at the time, machinery to make PROX was expensive. And then MIFARE and iClass came out in the late 90s, early 2000s, and their security was okay, but both of them got broken. And then DESFIRE EV1 and iClass SE, which is the iClass chip with the new SIO from HID, the software encryption on there, very secure cards. This was a good thing. And then EV2 and SEOS, even additional security features. So from left to right, that is how they stack up. If you are still thinking about cards, which according to our poll, not too many are thinking along these lines, you want to avoid for secure applications anything in the red rectangle, and pretty much anything to the right here is where you want to be in your new card types. So when cards are encoded, most of the time, cards are ordered with access control data, in other words, the number that's going to open a door, pre-programmed into the chip. And that's in the middle column, the secure data, and that's where your card formats, all that stuff comes into play. The chip also has a serial number or unique ID, and that is a number that any reader, pretty much any reader that reads these cards, can capture that number. It is not secret, it is not encrypted. It is unique in most cases, so it is an identifiable number with that card, but it's not considered a very secure number. And then the third on the right there, additional applications would be anything else you want to put on these cards, a transit app, anything else that's going on there, biometrics perhaps. And then, just looking ahead, how far can cards go? I picked this up at a trade show about 6 months ago. It's a real card. It really is a CR80 size card, in both in this dimension and in thickness. It's just 30 thousandths of an inch thick, like a regular card. It does have this number which generates an OTP. The screen generates a one-time password number, like an RSA token. The button on the bottom right here, you press that. And then it also has a magnetic stripe on the back. It has a contact chip that is connected both to the contact and to the contactless interfaces, and it has a battery to make it all go. It's hard to imagine what else you could stuff into a card, and it's also hard to imagine who would need all that stuff in one card. So that's how far they can go, in my opinion. Mark.
Alrighty. Everybody, we're ready for our next poll question. Are you planning to migrate to a higher technology card in the next 3 years or so? Let's see what type of responses we have on this one. Okay, I think we got everybody. Flip it around. 50% said hope so, 30% probably not, and 20% of you said we're going straight to mobile someday. Yes, the mobile. Okay, Dave, what do you think about that?
Yeah, that is interesting. The fact that a number of schools kind of hung back either with magstripe or PROX and did not in the last 10 years or so go to that, at the time, the latest step, which would have been DESFIRE EV1 or iClass or SEOS. They've hung back with the older technology. They're maybe in some ways in a better position to just leapfrog because they saved all that money. by not upgrading their technology in the middle, and now they can go to mobile. So there are ways to do that. But that's all about the credential end, the card being presented to a reader. In the background, what it matters to the access control system or to the payment system or any other system getting the number, but in this case, we're talking about the access control number formats. And you know, some folks who in campus cards don't pay much attention to this because that's the police department. You know, they put them in the access control system. We don't know about that. And others have spent a huge amount of time trying to get their formats aligned. You know, well, we use a 26-bit format, but the hospital uses a 32-bit format. You know, and we want to use the same format everywhere. What is this format? Well, just like a phone number could be identified from a 10-digit number by sticking 2 hyphens in there. You go, oh, that's a phone number, I see. Just the same way that when you have 26 bits, 26 zeros and ones on a card linearly, and they come streaming off that card in a row, if you parse them a certain way, you will get a facility code, which is a prefix, and you will get an ID number. And however your system parses those numbers is called the format. What is the shape of the number that we get after we parse the bit stream? And some of these formats are open. In other words, anybody can order any 26-bit format, and others are called proprietary because certain manufacturers they would create a certain format for a particular user or a particular dealer, and they would not sell that format to anybody else, which was a kind of security feature, but not anymore, because in the 20th century, again, it was hard to read and program PROX cards without that expensive machinery. But in the 21st century, we can pretty much clone any format. So people say, well, you know, I have this kind of format over here and I have a unique facility code and nobody else can get that. You're right. From the company that did that programming for you on your PROX cards, you're right. Nobody else, that company has an agreement to not allow anybody else to have that format. However, if I can read it with a $20 reader and then I can clone it with that same $20 reader, it doesn't matter what that company, you know, made generally available through other dealers or other entities. So what used to be considered a security feature is no longer. The only security now in these contactless cards is in the encryption itself. So that's important to know because a lot of people still are thinking in that 20th century PROX mindset. So managed formats are an interesting thing, and it's not so much now because you have a unique facility code, but rather that the company that is programming your cards is paying attention that your ID range is never overlapped. And if you are one of those institutions that has never had the experience of ordering cards and going, hey, these numbers are already in our system, then you have had a charmed life, because it has happened to lots of organizations somehow, either one or a few or a bunch. It's somewhere in the process, somebody got the numbers messed up and you got numbers that were already in your system, and that is a problem because you can't have duplicate numbers. The cards have to be reprogrammed or in some cases thrown away. So the managed formats, HID calls theirs corporate 1000. 1000 doesn't have anything to do with the format, it's just what they call it. The original was a 35-bit format, but it is no longer available because at 4095, they ran out of facility codes. So they had to create a larger format. They call it Corporate 1048, which is 48 bits long. So a lot more numbers. Now it's a much longer number. The facility codes are longer, and within each facility code range, each of which is unique to an institution, there are over 8 million ID numbers. So this is a step up in the Corporate 1000 program. Schlage, part of Allegiant, offers the CARDTRAX program, which was originally patterned on the Corporate 1000, and their first one was 35X. Surprisingly, 35 bits. If you have a facility code, Corporate 1000, you know, that and you want to look at another supplier perhaps, if Schlage has your facility code available, then you can get your cards from Schlage in that format. In PROX, in the encrypted cards, not so much. If you want something different and unique, then you can go to their 40x format. Now, once you go to the encrypted cards, these same formats can be are the numbers that the access control systems look for, and they can be applied to either type of card. So whether it's a PROX card, iClass, MIFARE, DESFIRE, EV1 or 2, SEOS, all of them are normally programmed with one of these formats. Also, other manufacturers that do card programming are now programming a lot of these formats. So if you can't get it from one manufacturer, you might be able to get it from another. Part of the reason this is a big deal is because, like I said before, if you have a number of different access control systems on campus, or maybe some combined campuses or a medical center, and you're trying to get one card to work across all those different systems, sometimes we've had very interesting exercises in trying to get the formats, a format that'll fit all those different systems. And often it can be done, but sometimes, like when we went through just very recently, they have one really, really old system, and it can only be changed physically at each reader by sliding dip switches. In that case, there's no way that any other format is going to work on that particular system. So that then became the format that all the other elements of the system had to use. So sometimes getting formats, if you're starting from scratch or you're throwing things out, you have one system, whatever, it's no problem. If you're trying to make one format fit everything, one size fits all, it can be a bit of a challenge. So that leads us right into this poll.
Next poll. How many physical access control systems do you have on your campus? See what we get here. Thank you all for responding swiftly. Okay. Perfect. Okay, we got 36% say 3 or more, 27, 5 or more, 18 or 2, and then we got a tie at 9% with 1 and 4. So it's a pretty good variation between all those. It feels like last time we did this, Dave, there was nobody that had 5 or more, but I could be mistaken. So it's a nice little bump there.
Yeah, that's a lot of complication for some of those schools. Just what I was talking about, you're trying to make formats work, you're trying to make one card work, whether maybe it's a magstripe and a PROX and another chip. It is a challenge trying to make one card be everything to every system. Part of the reason for that is demonstrated in this next slide here. It's because the readers they're complicated little devices. They do what they do well, but essentially regarding the system architecture, they are dumb. They collect the data from the card. They may or may not convert it to, in some way they convert it to data that the access control system can handle, and they pass it that way. So that's it. If the data comes in encrypted, the reader decrypts the data and then sends it to the controller. If it's not encrypted, it just reads it and streams it. So it's sometimes they're called transparent readers if they're desktop models, but the idea is data comes into the reader from the card and then goes straight to the panel. And so the panel at that point is just reading numbers that are coming in. So trying to get the card to work with a lot of different kinds of readers out at the edge is often a challenge. One thing to point out is in this kind of random diagram here, any weak link in your system sets the highest security level for your system. So if you have a really weak card and reader interface like PROX or magstripe, then your system is not terribly strong. If you have another link in the system that's also not so strong, then that becomes your weak link. And one of those is the Wiegand interface is also relatively newly vulnerable. Those are the wires that run from the reader to the panel, and the data's in the clear. The zeros go down one wire and the ones go down the other wire. And the timing is a big deal, but otherwise, there is a little device you can slap on those wires and it will transmit over Bluetooth and tell you what the numbers are, and you can reproduce them. And so with your phone, a little app that works with this device, and that device clipped behind a reader, you can open doors. So that is a vulnerability. There are also other ways that this data is vulnerable. And so a newer protocol called OSDP was developed between which provides a different communication between the reader and the panel. It's RS-485. It's two-way communication. So data can be encrypted from the reader to the panel. Also, information can travel from the panel back to the reader, which can be as complex as rolling the keys at the reader and setting reader configurations if the panel supports that. So this is something that has been in development for a number of years. It's out there. There are some panels that support it. The problem, of course, is that access control panels are in closets and everybody forgets about them, and they're not cheap, and they sort of stay there like for a couple decades or more. They're like skeletons. So until the panels are replaced, you can't do something like upgrade your OSDP. And a lot of times, even though an access control system may be not at all working well for an institution, but the software is inextricably linked with the access control panels themselves, which are expensive to replace. And so therefore, the infrastructure, the hardware infrastructure dictates the fate of the whole system, which means it's going to live another decade. So, there are new things out there, but replacing existing infrastructure is a big deal, and especially when it's hardware. So let's go forward and talk a little bit about access control system. PACS is physical access control system readers and mobile, because we were just talking about how readers connect with the panel. We're talking about how cards connect with the readers. In this world, the phone can also communicate with a reader, as we all know at this point, and a lot like a card. So if you have Blackboard Transact or just Transact, and you have their readers, those readers are integrated for the Transact mobile app and their cards. If you have HID Signal readers, their newest generation of iClass SE readers, so they're the first out of the gate with the new generation of readers. They include the OSDP I just mentioned. They include Bluetooth, can be built in. Before it was either one or the other, OSDP or Bluetooth. Now it can be both. And it includes enhanced NFC to read Apple phones or iPhones. So Signo, and it also has improved read range for SEOS and DESFIRE, and it is slimmer. So it's the next generation reader. It's pretty cool. Schlage has integrated mobile into their application for their locks. It's not on their readers yet, but they're coming out with readers before long. And Wavelinks has also introduced very capable readers, which can contain OSDP, NFC, and BLE, or Bluetooth Low Energy. On the doors, if you have locks rather than a reader next to the door, then you have the capability within each of these to read mobile and to read contactless, because this has been an important feature. So ASSA ABLOY, being part of the HID family, builds HID readers into their locks. Schlage builds the technology from their wall mount readers into their AD, LE, and NDE lock series. And Salto does their own thing. That is a Bluetooth solution, and they will read the app from Salto mobile app. So anyway, let's talk about encryption and interoperability. So I said earlier that the key to the security of the card and reader interface is no longer the format or even just that it's a contactless interface, but rather it's about the encryption. So this means the data has been scrambled. In other words, the number, it's a number. The number that we talked about, which is the format, 1, 2, 3, 4, 5 gets scrambled, and part of that scrambling in the encryption is another number called a key. And the key is unique, usually to the institution, and can't be known by anybody except the people who do the programming for those cards and readers for that institution. So they are used to lock sectors of memory on the smart cards. They're used to secure that data by encrypting it. And it can either be this one key from the manufacturer that's used across all their cards and readers, or it can be a custom key for that institution. If you don't have areas of your card encrypted, then they're usually just locked with what's called a default or transport key. And then often it's just ones. And so if you have a MIFARE card and you want to program some unprogrammed areas, you need to unlock those areas for programming. What's the password? All ones, type it in, boom, you're in there. You can replace that with your own password or with your own key. So when cards are programmed and secured with encryption using a key, the reader has to know the same key because it needs to decrypt that data. So it has to know that. So think of the keys like passwords. I think that's the easiest thing. People sometimes confuse keys with like a database key, where a key is an identifier for a record. But in this case, the key is actually more like just a password. It allows you access to the data. It doesn't necessarily identify the data in itself. The length of the key affects the security. So the MIFARE Classic cards have a 48-bit key. Now, 48 bits isn't bad. It's not very long, but it's not bad. But the other problem is the encryption algorithm itself wasn't that strong. iClass had a 64-bit key. It was, like I said, it was broken through the reader, but not that strong. And then DESFIRE EV1 and 2 uses a 128-bit key. Now, that's not twice as strong as a 64-bit key. It's 62 to the 64th times as strong, because in key length, increase in number of bits results in exponential increase in security. So all of this 128 bits is going to be good for a long time, until a company like Google gets a hold of quantum computing and gets it stretched out to 128 bits, and then we don't know what's going to happen. But that could be quite a ways out there. So for you science fiction fans. So keys are used to encrypt the data, and they can also be stored on the card in the encrypted form. So custom keys, if you had a key made, you said, we don't want the key that manufacturer puts on all their cards and readers for everybody else. We want our own key. Okay, great. Then if you get it from HID, it's called an elite key, and it'll be on your CEOS or your iClass cards. If you get it from Allegiant, they'll call it a custom key. Wavelengths has their own management program, the CC Custom Key Set Management, and because keys have to be managed, you can't let them out in the wild. If somebody learns your keys, then all your cards can be compromised. So you have to manage them very carefully. Not very many people should know them, and whenever they are transmitted, they have to be transmitted very securely. Talk to your IT people sometime about how they transmit keys and look after them. It's very important. Other readers that can read these cards is worth mentioning here, because if, let's say, for example, you're moving to a contactless card, and we want to be able to do print jobs, and our print management system will read these cards. Okay, well, check very carefully, because, for example, for this Konica machine that's pictured here, this is the actual spec from the document that I pulled from the internet for this machine, and it says here, Universal ID card reader, various ID card technologies. Can you assume that will read the numbers from your card? And the answer is no, you cannot assume that. It might read some numbers, it might read the card's serial number, but you have to find out. So just because a machine has an embedded reader, a time clock is another really good example of this. It reads contactless data. We just got a call this morning. Somebody got on the, hey, we need this kind of card, and we're trying to figure it out with for the time clocks. Like, oh man, I have to know the model number of the time clock. I need everything. I need to know everything about it, including what kind of reader is in it, to know if it's going to read the kind of card that everybody's walking around opening doors with at that same place. So you just have to really do your homework on things like what kind of reader is in there. And if you find out that the reader that's embedded, or maybe it doesn't have an embedded reader for your card types, then you can buy a lot of different kinds of card readers with wires coming out of them. And they can be USB, they can end in RS-232, they can be RJ45 to carry serial data through what looks like a Cat5 port. These are very capable readers. They can convert a lot of different card data into what will work on a machine like a point of sale machine or a printer. But it takes some experience and it takes some experimentation. Once you figure it out, you're all set. Like if you figure out this OmniKey reader on the upper left here works with your Konica machines, you set the programming profile for that reader, you figure out how it's going to plug into the machine, you can replicate that across all 250 of your print copy machines. But that first one can take some time. So anyway, having said all that, Mark, last poll.
All righty. So everyone, do you have a strategy for placing and ordering new card readers with an eye to mobile? Okay, let's see here. I'll share this. We're working on it. 71% of you say. That is awesome. And then we got a tie at 14%. Absolutely. And shucks, no. Okay, well, that's good. We're working on it.
All right. Yeah, no, that's really interesting. In fact, as we've been doing these over the last 5 or 6 weeks, it seems like every week mobile picks up some steam. You know, people are thinking every week, wow, if we just didn't have to print cards, if we could just go straight to mobile, how do we get there? And that is a really good question, and we'll cover that in another presentation coming up. I think we have one more mobile session left, and so join us again. In the meantime, that's all I got. And Mark, do you want to field any questions?
Yeah, we got a couple in here today. So, see here, how do we better assist the transit system on getting onto mobile credentials? That's a tough one.
Yeah, that's a real good question, because like what mobile credential transit systems, you have to look at what's in place, and they have a lot of hardware. When I was talking about, you know, panels, control panels in closets, transit systems have fare collection boxes or they have readers. So if you're talking about a traditional fare collection box on a bus or on a subway entrance, that's a lot of hardware that has to be updated, replaced. The reader has to be relocated in there. There are mobile readers. You know, there are readers that will read mobile data, and those can be inserted. And so that certainly is something that can be addressed. But transit companies are not known for being nimble and quick. They, you know, they're large bureaucratic organizations, and usually the people who are paying attention to things like the architecture of the fare collection system are not necessarily extremely well staffed. You know, they usually are short on resources. So we've had good conversations. We've had some success with cards. We haven't had mobile experience yet with a transit system, and a lot of that has to do with the existing infrastructure. So best thing is contact the transit system, talk to them, and if you want, bring, you know, we're happy to join you in a conversation, bring in other industry experts, and you know, just explore what's available. There are ways around this. Just you know, there are a lot of different ways, and so the conversation will probably take a lot of twists and turns. But if you hang in there long enough, then you'll probably get to a solution. Was that helpful?
That's right. There's there's always options. Yeah.
Right.
It's not just one thing. So, okay. Regarding low frequency PROX, my readers have pin pads on them too, but we do not currently use them. Would you suggest turning on the pin pad for a more secure access, or is it still flawed tech?
Well, no, certainly yes, that's what you call a second factor, something you know. You have the something you have is the card, and that's of questionable security. So, but your second, actually your PIN at that point is probably the better part of the security. It doesn't hurt, and if that's the best you can do right now, and you have some areas where you're really concerned about security, and you're able to turn those back on, then that could make sense. You definitely a big hit to convenience, that's for sure. So you need to weigh security versus convenience, probably in each of those various locations. On the other hand, if you're looking to upgrade at some point to a newer reader and maybe something with mobile or cards, but then you get into a much bigger project. So yeah, certainly turning on a pin pad could increase your security.
Nice. Here's kind of an interesting one. How expensive was that card from slide 21? And to follow up, what is the most expensive card you've ever seen?
That's great. I love it. I don't know what that card costs. I'm going to guess probably because these technologies, like if you bought 1 million of them, like they would hope to sell to the financial industry, I would guess probably in the $16 to $20 range, but maybe it would come down, the most expensive card we deal with or work around, because we don't sell them ourselves, are the CAC and the PIV, the federal government, U.S. federal government cards, both for military and for executive branch. But the cards themselves the plastic and the chip probably run in the, depending, $12 to $20 range. But with all the programming and preparation and background, it runs about $150 to issue one of those cards. If you want to buy that kind of card in like 1,000 quantity, just the chip in the card itself, those run more in the $30 or $40 range. So yeah, there's some expensive cards out there. You can definitely drop a lot of money, and but usually the more expensive the card is, the more money you have to put on the back end infrastructure to support what that card can do. So it's only the tip of the iceberg if you're looking at that.
So regarding that CAC card, it's really about, it's not so much about the actual product itself, it's a lot of the applications and everything to load onto them is the pricey part.
Right, exactly. And all the back end infrastructure that goes into supporting that card, how it's provisioned, how the data is pulled for that individual, the vetting that goes on. And yeah, there are a lot of services involved there too.
Nice. Okay, last one. Can I upgrade my existing HID SC wall readers to be OSDP compliant?
Yes, you can. I would think in the last 6 or 7 years, the I-Class SE readers, if you take it off the wall, you'll see there's a port in the back. I forget what it's, Mahashi port or something like that. But anyway, it's a little plastic port, and that is where you plug in the OSDP module. The only downside of that with those readers is that there's only one of those ports, and it is the same port that's used for Bluetooth. So if you were thinking of using Bluetooth on that reader to read Bluetooth credentials from a phone, then it would be an either or. You can have either OSDP or Bluetooth, but you can't have both. But if OSDP is your primary interest, then yeah, absolutely. You can plug in the OSDP there, do a firmware upgrade, make sure your panels are upgraded, and off you go into the world of OSDP.
How exciting.
Yeah.
All right, great questions, everybody. Thank you all for participating today. Please don't miss out on our next webinar on ID Printer Report. It's this Thursday, May 14th at 1 p.m. Eastern Standard Time. A reminder that each webinar does require its own registration. With that said, on behalf of Danny, David, and myself, be safe out there, and thank you so much for attending today's webinar. Goodbye.